Today, we will look at the second part of the VFR flight planning considerations, since as we mentioned in the previous video, we divided this topic into two parts. In the first part we talked about the flight plan distance, availability of visual checkpoints, terrain and relief characteristics of the area, weather conditions, as well as airspace structures and classification. In this second part, we will look at the standardized VFR departure and arrival routes, the maximum and minimum altitudes that we can fly under VFR, the available VFR cruising levels according to semicircular rules, aircraft range considerations, as well as sunrise and sunset times. So with this being said, let's start by looking at the standardized VFR departures and arrivals. The situation is that, at some airports, IFR and VFR air traffic management can be a bit complex, so in these cases, standardized departure, arrival, or overflight routes are designed for visual flights so as not to interfere with IFR traffic. If this is the case, during flight planning the planned route must be adapted to comply with these local procedures. Now, these standardized routes are published in the charts of each airport, and as these are VFR procedures, visual references will be used, such as towns, rivers, roads, railways, etc. Normally, no courses or distances are published in the chart, which means that it is the pilot's responsibility to plan the different headings and distances manually by himself. Here we can see an example of several VFR standard departure routes for Cali Airport in Colombia. In this case, both a chart and a textual description of the procedure are provided. Let's analyze more in detail the Cerrito 3 departure procedure. It establishes that after taking off, we have to climb on runway heading up to 4,000 feet, and then turn right to heading 090 towards a visual checkpoint called Manuelita. So as we can see in the chart, this initial right turn is most likely intended to clear the departure path and the CTR as soon as possible, so as not to interfere with other IFR traffic departing. Then, we have to make a left turn northbound towards a town called Cerrito, while climbing to 5,500 feet, which in this case is the altitude limit to avoid conflict with IFR traffic departing and arriving at higher levels. Then, after reaching Pichichi, we can expect ATC clearance to continue climbing, depending on traffic conditions, while flying towards the rest of the visual checkpoints specified in the chart. Now, some of these procedures may include specific altitude or speed restrictions, which may vary for each route segment. In this particular example, we can see that there is a table included in the textual description that specifies the altitudes at which we must cross each checkpoint, probably because there is traffic flying above and below these altitudes, and therefore it is necessary to exercise strict altitude control. Now that we have seen the standardized VFR procedures, let's continue with VFR minimum altitudes. According to the rules of the air published in ICAO Annex 2, except when necessary for takeoff or landing, or except by permission from the appropriate authority, a VFR flight shall not be flown over the congested areas of cities, towns, settlements, or over an open-air assembly of persons at a height less than 1,000 feet above the highest obstacle within a radius of 600 meters from the aircraft, and elsewhere at a height less than 500 feet above the ground or water. Here we can see a graphical summary of this rules. In case of flying over cities or towns, we have to look for the highest obstacle within a radius of 600 meters from the aircraft, and based on that obstacle, fly at a height of 1,000 feet or more in relation to it. Now, in case of flying over any other unpopulated area, we have to fly at a height of 500 feet or more above the ground or water. Let's see a more practical example of this. Here, if we are flying over the sea, the minimum altitude would be 500 feet. But now, let's say that the ground level on which this city is located is 1,980 feet above sea level, and let's say for example, that the height of the tallest building is 340 feet above ground level. This implies that if we plan to fly within 600 meters of this building, we will have to fly at a minimum altitude of 3,320 feet to comply with the minimum altitude rule. But if, for example, we plan to fly over an unpopulated area, the minimum altitude would be 2,480 feet. Now, having already seen the minimum altitudes for a VFR flight, let us now move on to the maximum altitudes. According to the rules of the air, unless authorized by the appropriate ATS authority, VFR flights shall not be operated above flight level 200 or at transonic and supersonic speeds. And apart from this, it says that authorization for VFR flights to operate above flight level 290 shall not be granted where a reduced vertical separation minima of 1,000 feet is applied. So apparently, the maximum altitude at which a VFR flight can operate is flight level 200. However, in most countries, the airspace above 18,000 feet is Class Alpha, where VFR operations are not allowed. So in summary, we would have something like this. VFR operations cannot be conducted above flight level 290 where a reduced vertical separation minima is applied. Then, according to ICAO Annex 2, unless authorized by the appropriate ATS authority, VFR flights are not allowed above flight level 200. And finally, depending on the airspace classification of the area we are flying, VFR flights are not allowed in Class Alpha airspace, which means that, in most cases, this is the limiting altitude for VFR operations. So having seen the minimum and maximum altitudes, let's now see the VFR cruising levels that we should actually use. According to the rules of the air, except otherwise specified by ATC or the appropriate ATS authority, VFR flights in cruise at 3,000 feet or more above the ground or water shall be conducted at a cruising level appropriate to the magnetic track, as specified in Appendix 3. The Appendix 3 in this case deals with the implementation of the semicircular rules of cruising levels. In summary, it states that VFR flights with a magnetic track between 0 degrees and 179 degrees will use an odd level plus 500 feet. While VFR flights with a magnetic track between 180 degrees and 359 degrees will use an even level plus 500 feet. In simple words, all aircraft flying eastbound will use odd levels plus 500 feet, such as 1,500, 3,500, 5,500, 7,500, etc. Or depending on the transition level of the area, these levels might be flight level 015, 035, 055, etc. On the other hand, all aircraft flying westbound will use even levels plus 500 feet, such as 2,500, 4,500, 6,500, 8,500, etc. Or depending on the transition level, these might be flight level 025, 045, 065, etc. The main objective of this semicircular system of levels is to ensure a natural separation between the eastbound and westbound traffic to prevent conflicts and possible collisions. However, this system is not practical in some cases. This is why in some countries, the semicircular rule is applied in a north and south direction, instead of east and west. In these cases, VFR flights with a magnetic track between 090 degrees and 269 degrees will use an odd level plus 500 feet. While VFR flights with a magnetic track between 270 degrees and 089 degrees will use an even level plus 500 feet. Some examples of this system are Spain, Portugal, France, Italy, and New Zealand. These countries decided to adopt this modified system because most aircraft within their airspace fly in a north or south direction, instead of east or west. So with all this in mind, let's see a summary of the minimum, maximum, and semicircular cruising levels for VFR operations. First, depending on the area above which we will fly, we establish the minimum flight altitudes. Then, depending on the airspace classification, we establish the maximum altitude at which we can fly. Then, within these limits, we have to take into account our magnetic track to choose an appropriate cruising level, according to the semicircular rules. So having seen this, let's now continue with the considerations related to the range of the aircraft. Basically, the range is a parameter that measures how far an aircraft can fly with a certain amount of fuel on board. In other words, it is the relation between the distance traveled and the amount of fuel consumed. A practical way to use this parameter is by determining the specific range, which corresponds to the number of nautical miles that the aircraft can fly per unit of fuel. So with this in mind, we could say that this parameter limits how long a route can be, or in other words, how far the aircraft can fly. This is a factor to consider in long routes, or when there is little fuel available on board. Now, it is important to also take into account the fuel required to fly to an alternate airport, and in addition to this, the regulatory final reserve fuel. Let's see an example of this. Suppose we are located at the airport A, and with full tanks, the manual of our aircraft specifies that we have a total range of 500 nautical miles. As we can see, this range allows us to fly without problems to airport B, and it is also clear that it is not possible to fly to airport C. However, airport D is right on the limit. The question is, under these conditions, can we legally fly to airport D? Well, if we analyze this situation, we would depart from airport A with full tanks, but we would arrive at airport D with empty tanks, and for obvious reasons, an aircraft must not arrive at its destination airport with empty tanks, since it must have sufficient fuel remaining to proceed to an alternate airport in case it results impossible to land at the planned destination. And in addition to this, it also must have some reserve fuel that allows it to fly for a certain period of time, which is specified by local regulations. So in this order of ideas, to obtain the actual effective range of the aircraft, the fuel to the alternate airport and the final reserve fuel should be subtracted from the range calculation. So in the previous example, we had a total range of 500 miles with 160 gallons of fuel on board. However, let's say that from that fuel, we need 20 gallons to proceed to the alternate airport, and another 30 gallons for the regulatory reserve fuel. This means that we have to subtract 50 gallons from the original 160 gallons, resulting in a total usable fuel of 110 gallons from origin to destination, which in this case corresponds to 350 nautical miles of effective range. Now, with all this in mind, it is now clear that it is not possible to legally fly to the airport D, since it is out of range. So, in summary, the total distance of the flight plan must be equal to, or less than the calculated effective range. Let's now continue with the considerations related to sunrise and sunset times. The thing is that, originally, VFR flights were designed to be conducted in daylight, which is defined as the time period between sunrise and sunset. Now, this sunrise and sunset times are not always the same, since they depend mainly on the latitude and the season. For this reason, sunrise and sunset tables are published annually by the Civil Aviation Authority of each state, and can be found in the Aeronautical Information publication. So, in the event of being forced to fly in daytime conditions, we have to make sure during flight planning that the entire flight is performed within the daylight period, including the flight to the alternate airport. In order to comply with this, we have to calculate the takeoff deadline. This is the time limit at which an aircraft may take off to ensure that the entire flight is performed within the daylight period. It is obtained by subtracting the total flight time from origin to destination, and from the destination to the alternate airport, from the official sunset time of the alternate airport. Let's see an example. Let's say that the flight time from origin to destination is 50 minutes, and the flight time from the destination to the alternate is 20 minutes. This means that the total flight time is 1 hour and 10 minutes. Now, taking into account the sunset time of the alternate airport, which is 18:05, we have to subtract the total flight time of 1 hour 10 minutes, thus obtaining a takeoff deadline of 16:55. Now, in some cases, there is an exception to this rule, since some countries allow VFR flights at night without restrictions, while other states may not allow this type of operations or may restrict them to certain routes or areas. In any case, prior approval from the Civil Aviation Authority is required. This approval will depend on several factors, such as the aircraft lighting, instruments and equipment, the instrument rating or night VFR approval of the pilots, and the lighting, facilities, and operating hours of the airports. I hope the information presented in this video was useful. If so, don't forget to share, like, subscribe, and leave a comment down below. Thanks for watching.